In today's video, we'll learn how to find the center of gravity. When dealing with a homogeneous, symmetrical body, the center of gravity must lie on the axis of symmetry, which is often the geometric center of the object. However, if the object is not homogeneous or irregular shape without symmetry, the center of the gravity can be found by taking the irregular shape and imagining lying it in an XY plane. Pick a position of multiple particles in the object that are free to rotate around an origin. After you have picked multiple particles and picked a position, then the torque produced by the individual particles of the object is measured by the weight multiplied by its lever arm, or mass times gravity times its displacement from the origin will give you the torque for that individual particle. After the individual torque is found for each individual particle, we can take the sum of the torques acting on the individual particles to find the object's center of gravity. And we can calculate the object's center of gravity by taking the sum of our mass of our particles times the displacement of the particles from the origin divided by the sum of the mass of the individual particles, where x subscript cg is the x-coordinate of the center of gravity. The same equation can be applied by substituting the x-coordinate for the y or the z-coordinate to find the center of gravity along its axis. So on our figures to the right, we see our first figure has a symmetrical shape where the center of gravity lies in the geometric center of the object. And in our second, we see an irregular shaped triangle where the center of gravity can be found by taking the x coordinates and y coordinates and applying them to our equation at the very bottom to find the center of gravity of a irregular shaped object. So in our example below, let's see how we can find the center of gravity of an airplane. In our example, it states that the center of gravity of an empty 1,200 kilogram airplane is located 2 meters behind the pilot's seat. When loaded, the airplane has a 75 kilogram pilot and a 55 kilogram passenger in a seat beside the pilot's seat, and 95 kilograms of luggage located 1 meter behind the pilot's seat. Where along the midline of the airplane is the center of gravity of the loaded airplane? So if we start by summarizing the information we're given that the weight of the empty airplane is equal to 1,200 kilograms times gravity will give us the weight of the empty airplane. We know the weight of the pilot is 75 kilograms times gravity, and that the weight of the passenger is 55 kilograms times gravity, and that the weight of the luggage is equal to 95 kilograms times gravity. And we're asked to find the center of gravity of the loaded airplane. So our equation to find the center of gravity is equal to the sum of our masses times its displacement divided by the sum of the masses. And to our equation for center of gravity, we would get that our center of gravity is equal to the mass of the pilot, which is 75 kilograms. If we make the pilot's seat the origin on the x-axis, then the pilot's weight is displaced 0 meters plus the mass of the passenger, which was 55 kilograms, and their displacement is also 0 meters plus the weight of the luggage, which was 95 kilograms, and its displacement behind the pilot is 1 meter. plus the weight of the empty plane and its center of gravity, which was 2 meters behind the pilot, divided by the sum of our masses. So our masses were 75 kilograms plus 55 kilograms plus 95 kilograms plus the weight of the airplane, which was 1,200 kilograms. And if we were to multiply, sum up, and divide our values, we would find that our center of gravity along the plane in the x direction would be 1.75 meters behind the pilot's seat.